Right, so we could talk about discrete random variables, probability distributions, and so obviously there's a little bit of terminology here. It's nothing really to worry about. If you think the term discrete, discrete just means taking a whole number, a variable. It's just something that can take a variety of values. And random suggests that there's some sort of probability to it. So the best way that we could do this is look at some examples. So in the PDF file that I've sent you, you will see that we've got lots of examples to go through. So I'm going to go through those examples with you now, and then you can then have a go at the questions. If you feel kind of confident, then obviously work through the examples yourself, and then you can have a look and just make sure that you're okay. So let's have a look at the first one. Obviously, you've got this in your PDF. So the first question that we've got here for our first example says draw the probability distribution table for x. Right. Okay. All this means is if I'm just going to draw a little table now. You're all quite happy if I go and throw a dice, roll a dice, then the probability of each outcome is 1/6 if it's fair. So here are the different outcomes that we've got, and here are the probabilities associated with each one. And then we use little x just to talk about the different values that it could be, and then we talk about big X. You tend to use a big X to stand for the discrete random variable. So here you just be talking about, right, what's the chances of getting a 1 over 6? What's the chances of getting a 2 1 over 6? Obviously it's uniform, it's all going to be the same. So if we talk about a probability distribution table, that's all we're actually talking about. All right. So let's have a look on again. All right. So there's a little bit here just to draw your attention to remind you about. I put this in just because if you look at this, it just means that all possibilities add up to 1. Okay, and this is the same with this here. It sounds and looks a little bit more complicated, but actually it's, if you look at this example here about throwing a fair coin, obviously the two outcomes there, heads and tails. I think this was talking about the number of heads that you were going to get in one throw. Well, it's either going to be 0 or 1, so therefore half plus a half, so it's got to be equal to 1. So again, let's have a look at our couple of examples. Right, this is the best way to do this. So a fair coin is tossed once, and the number of tails x is counted. Write down the probability function. Right, it's talked about probability function. Right, okay, that sounds a little bit scary. Well, it's basically the same thing as drawing out a table. But let's actually think about, so what have we got here? Let's just jot this down. It's just about getting our notation correct. A fair coin is tossed once, and a number of tails, x, is counted. Write down the probability functions. Right, so how many tails are we going to get? We're either going to get 0 or we're going to get 1. So the different numbers that we can take are, it could be x, could be 0, or it can be 1. What's the probability of getting 0 tails? Was half. What's the probability of getting 1 tail? A half. There you go. So it's just always like that. I could set that out in a very simple table, but it's probably easier to write it down as a function. It's probably better explained on part B here. A biased coin for which the probability of heads is 3 over 4, tails is 1 over 4. So again, it's talking about, so if I tossed a coin, and we're counting the number of tails. So let's have a little think about what's happening just here. That's going to be equal to, so the number of tails that we're going to get is either 0 or 1, but the probabilities of each one is different. So x could equal 0 or x could equal 1. What's the chances of getting no tails? Well, that would mean it landed on heads, so that would be 3/4. And what's the chances of getting 1 tail? Well, that would be 1/4. So we set it out like that. That's what a probability function means. Yes, you could equally set that out in the table, okay, it would be no problem at all. All right, but if it says probability function, that's how it wants you to set it out. Right, example 3. Here we go. Right, so what have we got here? Wait a minute, we've got a funny letter K in there. Right, we need to work out what the K value is. Right, what do we know about these 3 probabilities? We know that they add up to 1. So all this means is that the probability of getting 1, if I'm looking at our probability function here, if I just substitute 1 into there, it means it's 1 times k. So it's 1 times k. If I substitute a 2 in, it's 2k. And if I substitute a 3 in, it's 3k. There we go. Right. I know that this, at this equals 1. So 1k plus 2k's plus 3k's is equal to 1. 6k equals 1. So therefore k must equal 1 over 6. There you go. Once I know that, I would probably go back now and I would write in 1 over 6, 2 over 6, 3 over 6. Now, whoops, got 3 there. And obviously you could write a third there and a half, but actually you'll quite often ask a question. It might say, what's the probability of getting a score of 2 or more? Well, if you've changed it, it just makes your life slightly harder, doesn't it? All right, so that's all you need to do there. Right, example 4. Remember, pause, carry on, okay, come back and check it. Right, hopefully you're sort of starting to get the idea here. Right, now this one, it says find the value of A. Well, what do I know? That this plus this plus this plus this equals 1. So what's that? 0.3, 0.6, 7, 8. So A has to equal 0.2. Right, now look at this. What's the probability that X is more than or equal to 2 but less than 4? So that's those ones, not that, not including that, because it's less than 4. So the answer to that, so part B is 0.5. It's those two. What's the mode? Well, which one happens the most? 2 is the mode. Right, there we go. So these questions are kind of quite, once you get the idea, they're reasonably straightforward. It's just getting used to the terminology a little bit, not being scared by sort of the table that's in front of you. So example 5, what do we got here? An unbiased 6-sided dice has got, okay, dice is rolled twice. Right, okay, so I'm thinking the best thing that I can do here is to draw myself a little sample space diagram. So if I just draw a quick sample space diagram, and this will make my life so much easier. Alright, so here's the first throw, and the second throw, and the dice is rolled twice. That'll be the sum of the 2 scores. Okay, I was just checking 2, 2, 2 in terms of what to do. Sometimes it catches you out and asks you to multiply them, and it's really annoying to end up getting it wrong over something so daft. Okay, and as you can see, it only takes a few moments to go and fill this in. I would strongly suggest that you do fill these kind of things in, because it just makes it so much easier, I promise you. A number of times I've done these questions and I've tried to kind of take a bit of a shortcut, and then you end up just making sort of stupid mistakes in there, and you shouldn't be making those kind of mistakes. Okay, so someone's going to find the probability distribution of X. Right, so let's pop this in a little table. It's probably the easiest thing to do. Okay, so there we go. So what are the different scores that we could get? Well, we could get a score of 2, we can get a score of 3, we could get 4, we can get 5, and we can get 6. And whoops, just squeeze that in there. Right, how many times Do we get a 2? Obviously all this is over 36. So how many times do we get a 2? So we've got 9 over 36. Now again, I tend not to cancel these down yet, right? Obviously if I'm finishing the question I probably would. Right, 3s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 over 36. And 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 5, 1, 2, 3, 4. And 1, 36. Right, how can you check it? Make sure it adds up. Okay, make sure it adds up to 36. So what we got? We got 22, 31, 36. Right, okay, I'm reasonably confident that we've done the right thing. Find the probability that x is less than 5. Okay, so that's that lot, isn't it? I think you'll find that the probability that x is less than 5 is going to equal, what's that, 31 over 36. Right, there you go. That was so much easier because I didn't actually cancel anything down. All right. Okay, example 6. What do we got here? So a similar sort of idea. Look, game involves rolling 2 fair dice, but this time we're going to be interested in, so obviously we've still got the sum of the scores, but again, I need a sample space diagram here. Right? If you don't do it, it will be confusing. If you do, life is easy. Okay? Because we want to get an easy life. Alright? Especially when you're getting old, brain cells don't work in the same way. Here we go. So, what are we interested in? If the sum of the scores is greater than 10, then the player wins 50 pence. So if it's greater than 10, so where does that happen? So it'd be easier if I was doing this on squared paper. So that happens with a 5 and a 6. I'd get 50 pence. I'd get 50 pence there, and we would get 50 pence there. Nowhere else do we get that. Where do we get 20 pence? I'll tell you what I'm going to do. So 20 pence if it's between 8 and 10. Otherwise they get nothing at all. So 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is how much you're winning from the game. Oh, wait a minute. Nearly put that down then. So that's an 8. So that's 20 pence. So 0, 0, 0, 0, 20, 20, 0, 0, 0, 20, 20, 20, 0, 0, 20, 20, 20, 0, 20, 20, 20. There you go. Look, it didn't take long. Now, let's just draw a quick table for our probability distribution. What are the different outcomes that we've got? It's how much the player wins. Okay, so 0, 20 or 50. Those are the different options that we've got. Now let's write down the associated probability with all of those. So 0. I'll tell you what, I'm going to do it the other way around. I'm going to do 50 first because I don't need to think about that. And then I'm going to do 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You could cheat at this point and obviously take those away, but I want to just make sure I've got it right. So I've got 6, 5, that's 11, 15, 16, 17, 18, 19, 20, 21, over 36, 21, 33, 34, 35, 36. There we go. We're in there. Excellent. Right. Game costs 15 pence to play. Find the probability of making a profit. Well, where do we make a profit if that happens? So the question is, what's the probability that x is more than, whoops, 15? A bit careless, wasn't it? Equals, oh, that's nice, isn't it? 15 over 36. That's the probability of making a profit. So, what's that? 3 goes into that. What have we got? 5 twelfths. There we go. Right, and on the last question, so example 7 There we go. So sometimes we talk about a uniform distribution. If you remember that first one with the dice, each outcome was 1/6. So on this one, lottery involves a ball being picked at random from a box of 30 balls. So each outcome has got a probability of 1/30. So it's probably easier again if we write it like this. It's always going to be the same. 1/30. What are the different values that x can take? It can be 11, 12. Oh, I don't want to write them all down to 40, do you? So let's cheat and do that. There you go. That seems sensible. Yeah, I think that's pretty obvious what that means. Okay, write down a probability function and, oh, wait a minute, nearly missed this. Find a probability that x is less than 20. So that's the probability of, so it's not including 20, so it's 11, 12, 13, 14, 15, 16, 17, 18, 19. I think you'll find that's 9 numbers, so 9/30, right? So when you've got a uniform one, they tend to be a little bit easier to do, okay? So, right, so you can have a go at doing those questions there. Hopefully that will make sense, and then we'll move it again on, we'll move this on again next lesson, all right? Okay, so good luck with those.